And soon networks will be self-driving, leveraging new learning-based technologies to automate operational network functions and reduce OpEx. Watch this NMG-hosted executive speaking panel with leaders in the ORAN and 5G sectors discussing how telcos can accelerate their 5G networks by leveraging disaggregated and open reference architecture solutions that use open components with standard APIs from a multi-vendor ecosystem. To my left is Neeraj Patel. He's Vice President and General Manager of Software and Services at Radisys. Next to him is Dr. Qilin Yi. She is Chief Scientist, Wireless Technologies at China Mobile Research Institute. And next to her is Durga Satapathy, Director of Technology Innovation and Architecture at Sprint. And panelists, welcome.
Thank you.
Well, thanks all of you for joining us. We know there's a much larger event just a couple blocks down the road, and so we appreciate your time and being here. Durga, we haven't actually spoken in front of the cameras anyway before, so we appreciate meeting you and then in your time as well.
My pleasure.
If you don't mind, Durga, I want to start with you. The title of this panel is ORAN Architecture for 5G. The question is, and this is more of a sort of a 30,000 foot setting the stage for the audience, how is the network becoming more complex really with the advent of 5G and the other technologies surrounding that?
Yeah, a couple of things come to mind. The first thing I'll point out is we are not switching to 5G instantaneously and shutting down 4G. So 4G continues and will probably be there for several years. So as we look at what's happening right now, it's what we call the non-standalone mode that all the operators are pursuing. So we have 4G and 5G coexisting together. Operating those two technologies together brings in a level of complexity in general. Furthermore, 5G is very different from 2, 3, and 4G. There are a lot of different use cases, a variety of use cases that we're looking at. It's sheer immense in terms of the variety in bandwidth, latencies, and applications. So EMBB or enhanced mobile broadband is one category. You got the URLLC, the low latency applications, and then the massive MTC. If you look at all of these things, that's never been done before. So that is one reason why it becomes more complex. And the third thing is, even for a single technology, as we look at how the 3GPP releases come out, and then we have to take it into our labs, we do the field testing, then we roll it out. There's a lot that goes on in making it commercially viable. Now we have to do that in concert with 4G, and we're looking at multiple releases, 3GPP 15, 16, and 17 coming in, enhancing, and we have to support all the new use cases while keeping the legacy ones intact. So those are some of the factors that I think is making everything more complex.
Yeah, I think Durga is making a very good point and quite comprehensively. But if we try to simplify and extract the key elements that contribute to the complexity, is really, like Durga said, multi-red, right, coexisting. In some cases, even 2G is still around. In some places, that 3G is around, and then the coexistence of 4G and 5G in the foreseeable future. That is one element. And then the fact that we are also going through multiple bands. We have low band, mid band, high bands, across the different frequency bands. And in terms of technology itself, I believe massive MIMO bringing in additional complexity. That is not just only one technology element. We actually have a much more flexible air interface. We very early on, we called it SDAI, software-defined air interface for 5G, which is necessary from the onstart because we're trying to address such a large variety of usage scenario. We're trying to not only enhance consumer use experience, bring new capability, but also trying to enable multiple type of categories of vertical industries, which has very, very different service requirements. And the fact that we also start with 8 KPIs for 5G, even before the standard work gets started, also shows you that we are expecting much more flexibility that comes with complexity. So that certainly makes it a sort of mandatory that we need to have much more automated solution to deal with this level of complexity in the future.
Neeraj, more demanding applications making the network more complex.
Yeah, absolutely. So if you just step back, 5G, there are so many vertical markets. There's this whole public-private networks. Almost every person who dreams of an application says, oh, it's 5G. And that adds, to Chilin's point and Durga's point, massive levels of complexity in the network. If you look at, here are the operators. Managing one box is painful. Imagine this disaggregation brings multiple boxes. Now you have this management overheads. Now the automation's coming in. We're hearing words about machine learning. So there's so much stuff going on in this little word called 5G. Also, we speak and focus a lot in RAN only for 5G, but let's not forget the transport network that has to evolve, and every operator seems to have something funky and some incumbency and some little complexity in the way they've architected their entire RAN, beginning from 2G now coming in, and as they wade into this sort of 5G little zoo, right, of how are they going to make things work. And I think that on PowerPoint looks really easy, but when we start getting into how are you going to get this call to go through, and the backhaul latency, the front haul, the mid haul, these are all these different nuances that are kicking in that's making the network architects and the guys who are rolling out these networks sit back going like, well, that's great, guys, that we're all thinking about all this disaggregation. It's really great that we're thinking about all of these different use cases, but have you looked at the deployment topologies and what this really means in terms of how we'll do the network planning? And I think that's adding to this whole complexity.
Durga, clearly open interfaces allow for multi-vendor deployments. What is that really doing to maybe the evolution of the supplier community, but also the operator community? And maybe with an overlay discussion about the services that are allowed under that umbrella.
Yeah, that's a good question. So first of all, let me say the whole motivation for us to look at this stems from the fact that we want to enable nimble, smaller players to come in that are innovative. And we want to also leverage the open interfaces for exactly that same reason. That instead of relying on trusted vendors, but from an end-to-end perspective, you typically go with traditional large OEMs, and you have an end-to-end solution that you can rely upon them for. This allows a slightly different model of working things out, where you might say, I'm getting great service from my legacy OEMs in all of these areas, but some of them are better in one, some are better in the other, and some are better in something else. But I don't have the capability to actually take these best-of-breed elements out of each one and get that in my entire set of markets. What this might enable us to do is to say, hey, maybe I'll pick this best-of-breed vendor for the CU element, this one for the DU, this one for the RU, someone else for system integration, and combine the best of everything to leverage what's available to us from an open source community perspective in terms of getting features done faster, time to market. All those benefits come with this model. There are challenges too to be thought of, because now you have more players. You have to make sure, like Neeraj was saying, there's operations to be looked at, troubleshooting, management, all those things now have to be looked at a next layer. So those are some of the pros and cons of looking at all of these approaches. But in general, I think this open API, the open RAN model, gives us a whole new approach that we really need to look into and make it work for us to be able to meet all the challenges of the 5G we just talked about.
Traditionally, I guess our industry tend to rely on very much almost an end-to-end integrated delivery.
Yeah.
But that, of course, has its advantage in the sense that for operators, it's simpler, right? We get a whole solution, and then the performance should be guaranteed for whatever we had predicted that we need. But in the future, we need enough flexibility to address new requirements, new opportunities. And if we can, like Durga said, if we can take advantage of whoever is best in a particular piece of hardware, particular piece of software in the end-to-end system, then what's required is open interface. So that really, whenever we have a new enhancement of the capability, or we have a new function that we can introduce, we can just mix and match. And that requires open interface. So open interface is a must to have. There has been traditionally a lot of so-called standardized interface that were not really completely open. So one of the work I think we jointly are trying to accomplish is to address the key interfaces in our end-to-end system in a way that if it came out of a related standard organization, that it's maybe 80%, 90% done, but it's really not comprehensive enough to make it really truly open to allow multi-vendor interoperability, then we'll make sure that whatever needs to be done is done, so that we can look at our system with every key interfaces providing the multi-vendor opportunity. Yeah, and the thing is, we do see that with important deep convergence of our industry, CT and IT industry, and the DT industry, ICDT deep convergence, there are talents, expertise in very different domains, and the open interface will provide us opportunity to take advantage of everybody's expertise in their respective domain. Yeah.
Wanted to open the discussion, Neeraj, and it's an important discussion to have about RAN being driven by the supplier community and the service provider community. I was going to say as opposed, but it's not as opposed, and the service provider industry. Why is it important to make that distinction, and why is it important to have that discussion?
So, great question. I think we can talk about this for hours on this panel right now, but to build on what we were discussing just 2 seconds ago, if you look at the evolution that's been going on, a lot of it was driven by sort of the supplier community, so to say. And when we are listening to the operators, and they have certain thresholds of these are our pain points. These are the things that we need. To Durga's point, vendor A, B, C were all good, but vendor A is doing this better and vendor B is doing this better. And with open interfaces, with the openness, true openness, not just open because we are all following one same standard, interpreting the standard differently. So it's not really open. So let's really follow the true openness. It's now letting us go into this real multi-vendor ecosystem. And to get into a true multi-vendor ecosystem, the operators have also taken the lead. The ORAN Alliance is a great initiative that is actually, symbolizes the operators taking the lead and saying, guys, we all want to come together on a global stage and drive this so that the adoption of 5G is in a much smoother way globally. Yeah, there are always going to be nuances about how everybody will deploy this, but I think you want to get to a stage where you have this flexibility of true disaggregation to kick in. And that's the difference that's happening today, where the operators are defining that, yes, these are my use cases, these are the deployment topologies you should be thinking about, these are the KPIs that we are driving towards. And this then lends itself into principles of, this is what cloudification should mean, this is what the front haul should mean, this is what the mid haul and the interfaces should all mean. And that's what was, I think, in my personal opinion, missing earlier, where earlier it was very standard based, but everybody was interpreting it differently.
Yeah.
And that really was then getting into a mishmash, and then we're coming into the economics of running those networks were getting expensive. And that's one of the key challenges that the operators today want to address is, how do we make this network so that it is functional, economically viable, and something that can then be maintained and scaled in a very efficient manner.
Yeah, and also in terms of, I think, earlier point made about time to market, I think our industry has been experienced for the past several decades with kind of a long time window for upgrade. For every generation, we say, it's 10 years or 12 years or something. And with fractional generation, it's also multi-years. But that's all, I think, consequences of a non-open architecture, because we are really doing, for the most part, every piece coming from the same vendor. And that's a big burden responsibility on one suppliers in any scenario. So in the future, we would like to see that we can do upgrade, we can do enhancement, wherever the technology or solution became available in our end-to-end system, whoever the solution comes from. And that will definitely enhance the vibrancy of our overall ecosystem, not just for suppliers, but also for operators. I think we will all be able to serve our customers, whether it's consumer or vertical industry, much better with that kind of a future.
If I may add one point to that, you might hear, if you ask an operator question, do you want this or this or this? Typically they'll say yes, yes, and yes. So in this case, I'm going to do the same thing. I want it low cost, I want it better performing, and I want it yesterday. Sure. Right? But I think this model can allow us to get there. And to some of the points that were being made by my esteemed colleagues here, the real fact is, as we look at legacy OEMs that we've been working, great model for the past decade or so, take a single OEM, they're serving multiple operators, and typically typically operators send in a wish list of requirements, and then they go through their product line planning and they say, yeah, you know what, I can only do this in the next 3 months, the next 6 months, and then out of 20 requirements that we said, we may get back maybe 7, 8, or 10, and for the other 10, you say, okay, you put in so much millions of dollars, and you might get the other 2, and that too won't happen in the next few months. It'll probably be 6 months. In this case, we might have an opportunity, leveraging the power of the open source community, that different people can work on a certain set of features, and we might have actually all of them be available in the time frame we need it, allowing us to sort of pick from what we need. Different operators can really pick from all the features they really need, rather than being restricted from a resource or a supply perspective. So that's, I think, another benefit of this whole approach.
And I want to address that issue of being open. It's actually a multifaceted keyword for us in the future. It's not just open interface. It's also taking advantage of the open source software community. And moreover, for the hardware, we believe by providing what some call white box, but it's really the open reference design of hardware. By offering this to the marketplace, to the ecosystem, we will enable many more that may not be tier 1 telecom provider, but tier 2, tier 3, tier 4, that with this lowered technical entry barrier into the market, they will be able then to start with this open reference design of the hardware and then add in their special sauce, right? Maybe their new algorithm to enhance the performance, or maybe some new functionality on top of the basic default reference design. So I think open for us, looking in the future, is open interface, open source software, as well as open reference design for hardware.
Yeah, I totally want to underline that, because one critical key here is innovation. And what's happening now is that if you look at the number of vendors that are there today trying to solve this RAN, and RAN is not easy compared to the number of vendors that are there maybe 15 years ago. It's increased, which leads to innovation. There are vendors who are doing amazing things, taking a critical piece of the network and saying, this is where we are excelling in. And the open API, at least now, lets us bolt all these different pieces together to really get true best of breed. And I think that that's critical, because that eventually drives the economics of this. And this is how the networks are getting actually more efficient. I mean, we were not talking about AI, blockchain, and ML 3 or 4 years ago. So this has come in because the architecture is now blended itself to allow for this openness in the innovation as well. I think that's critical.
Well, let's talk further about AI and machine learning and deep learning techniques. Give me an example of how that embedded intelligence is in that RAN, or those layers of RAN architecture.
Yeah, so if you look at the ORAN Alliance architecture, they have this area called RIC, the RAN Intelligent Controller, and then it's near time and non-real time. Within that, I would say the best use case, think of something like traffic steering in, or network slicing. A lot of this is now getting done within the RIC through closed loop automation. Networks want to get, you want to now provision for X traffic needing X bandwidth on a certain slice, X traffic needing such latency requirements on another slice. And there are numerous use cases about this, where you can take use cases for EMBB, URLLC. But if you look sort of a little bit deeper into how the RAN gets structured, and then the RAN end-to-end from the RAN all the way to the core, you're now talking about having slices of the network that are made available on demand. There are use cases of these operators who are saying, I can give this chunk of my spectrum out to another virtual mobile operator, and they can now actually operate this network, and I can provision this and provision that. So there's a whole new economic model that is also crept in, and the technology that's driving it is network slicing. And how this is controlled, the brains of this come in through the AI piece that's sitting in your RIC. And then you have a plethora of X apps, and that's going to really get fostered by multiple different people coming in saying, I have these really cool apps that are going to now run in here. There are these different algorithms that we are providing. So what was traditionally the SON element, all sort of headquartered in one portion in the CU alone, is now getting split up into the RIC, and it's being opened up for doing a lot more than just understanding, neighbor discovery and power control and this and that. So I think that's really where AI is kicking in, and networks are getting more self-healing. So machine learning, the networks know how I can move the load. If a certain cell site is getting heavily loaded, how do I move these calls onto a different part of the cell? And this is getting more and more automated in terms of ML. And I think that the networks are going to look very different. And the demands that we spoke about initially when we started off this discussion are the ones that are actually driving this. And all the engineers, all the network engineers thinking, okay, how do we now enable those use cases? And that's where this comes in.
Yeah, actually, from the onset when we launched the ORAN Alliance, a simple slogan was for the open and smart RAN in the future. And the smart is bringing data analytics, machine learning, AI, all this capability into every layer of our network, because we know that there has been great success of these technologies in more like at the higher layer, the application layer, okay? But we really see great opportunity and benefit to bring it in through every layer of our network. And so start from thinking, when you started the discussion today about the complexity, right? But really, we will bring in this capability, we will completely transform and revolutionize the way the network from the time of planning, deployment, optimization in the early stage, through the operation. In the operation phase, where you will see that you will see a lot more functionality coming in for automated management. So in the management plan, we will see this technology being introduced. Actually, as we are speaking, they are being introduced already. And the next step is from coupling with our rigs, the non-real-time rig, into the near real-time rig, it will go into the control domain. So because also in the future, our network will be built with decoupled hardware and software, with decoupled user plan, control plan, as well as decoupled, proto stack with radio resource management type of functionality. We will see management, control, and maybe further down in the road, even, the hardcore of our RAN, which is the physical air interface, the PHY layer, you will also see the AI and machine learning element into it. One of the things we are doing right now is actually bringing this technology even to the RU's power amplifier. We are bringing AI so that the power amplifier can improve its energy efficiency, and with a unified platform where every single power amplifier in any scenario from any vendor of any model can benefit from this unified platform. The first thing you will see large area introduction would be in the management and automated OAM space. Okay, and like Neeraj has already shared, we already are doing it with many current functions, not even waiting for 5G. Even in our 4G and our existing network, we have introduced this kind of technology to optimize our energy efficiency, to optimize the user experience, and to predict traffic, predict mobility, predict the loading of the network. So, in short, we would like to enable the network in the future to almost like it knows where and when to use the minimum resource to consume the minimum energy to provide the maximum experience for the user.
Durga, anything to build on as far as that closed loop automation aspect?
I think my colleagues covered it really well. The only thing I'll add is, AI is like table salt. You can apply it in anything. but we do see the need for that growing as we look at the variety of use cases. The architecture that Neeraj and Sheelan described with the non-real-time rig and the near real-time rig and the feedback loop, that is perfect for doing what we need and to enhance the traditional models to serve the variety of functions that we see a growing need for.
Yeah. And I can tell you, when we were all in Costa Rica last week with ORAN Alliance, this was one of the most interesting work group sessions.
Yes.
Lots of brilliant ideas, lots of use cases, and lots of how do we connect the dots. So this definitely is one area where we think the maximum number of innovative ideas are being generated.
Totally agree. Yeah.
So Durga, I'm going to start with you and go down the line here. Quick fire answer. Let's say in Barcelona, even that quickly, what do you think we should be talking about in the ORAN space, or talking about more, maybe that's a better way of phrasing it, talking about more in the ORAN space under the auspice of 5G? What would be your suggestion?
I think we should look at what we've already done, which is in the front hall space and the disaggregation, but then look at how we can take real products out, leverage what we've been discussing all around, and how soon we can get that out in the open. Actually, have a way of comparing the performance that we have with legacy networks and what the innovation capabilities that this can bring. Now, that's a lot, but if we can hit even half of that, that'll be a great accomplishment.
Mm-hmm. To me, I think we have to keep in mind that ORAN Alliance is a quite young organization. We officially only was established October last year.
Yeah.
So now it's about 1 year anniversary. But in this period, I believe with all the support and enthusiasm of our overall ecosystem, there's so much momentum going on. We have already now, I think, around 130 members, and that covers almost all segment aspect, hardware, software, chip, solution, and equipment, and I think every pieces that we can think that we need. Okay, we have players from our overall ecosystem joined. And so in terms of the open source software community, there will be the first release in November, our Ember release, that are composed of right now, currently, it's already more than 1 million lines of code from more than 60 contributors, 12 PTLs, and I guess between 10 and 20 companies contributing to it. And in terms of the white box prototype, we already started with the indoor picocell, which is, as we're speaking, in field trial phase already, and coupled with a new architecture that includes front hall gateway to provide a lot of flexibility in the deployment scenario. So this will be, while we're speaking, we are going into the field trial phase. And December, there will be the first ORAN Alliance Plugfest in a global sense. So I think by Barcelona, MWC, there should be a lot more update and a lot more to look forward to, and to start planning what we should have by the second anniversary of our alliance.
I'll keep it very simple. I want to have in Barcelona, what I would love to see is a drop-down click list of here are RU vendors, here are DU vendors, here are CU guys, here is this architecture, and we can do this mix and match. The ORAN Alliance Plugfest that are being planned is a great first step towards, is this now moving from, I keep calling it from PowerPoint to reality. And this is a first test for the community, all the vendors in different aspects, shepherded by the operators to come and actually say, okay, let's actually make and show what is really working. And this, I think, would be great if we can have this in Barcelona, because this will actually show the commitment that, this is a juggernaut that is just not going to stop rolling. And I think that would be perfect to see.
Agree.
There's no shortage of sort of subtopics under the ORAN and ORAN for 5G topic, so makes my job easier. Durga, once again, I mentioned at the top of the show, it's good to have you. We've certainly engaged with Sprint and your colleagues and your former colleagues for a number of years, so it's good to have you and meet you as well.
Thank you, my pleasure.
Thanks for your time. Chilin, I feel like you spend a lot of time in the air. So I feel like the next one we should do on like an airplane, so in between cities.
Yes, let's schedule that.
But I hear you're heading back to Beijing, so finally heading back home.
Yes.
And NMG will be in China as well. We can talk about that later. So maybe we can actually be in your backyard at this time.
Yes.
All right. And Neeraj, as always, been a supporter of NMG. We really appreciate that. And of course, making all this possible. Appreciate that as well.
Always.
Thanks for your time. I want to get you back to your meeting, hopefully on time.
Yeah, thank you.
And to our audience out there, once again, NMG would like to thank this panel for their contribution to ORAN Architecture for 5G. For this executive panel on demand, please go to thenetworkmediagroup.com. So long.